We learned about the labeled arrows, how to render them in Canvas. Canvas doesn't support multi-line, so that needs to be handled. clearRect versus clipping. clearRect is a lot faster, and always try to use off-screen canvas when you have the repetition. If you are repeating some steps, just move it to the off-screen canvas. Single polyline is more efficient than multiple polylines. Floating point values we should definitely avoid, and always round off to integers. Rendering labeled arrows in SVG and masking to remove the overlapping area. And drawing arrow in paths seems to be faster, but it can turn out to be complex depending on how complex your shape is. Today I'm going to talk about, the focus is going to be about Canvas, and I'll be deep diving into one of the widely used features, which is labeled arrows when it comes to whiteboard, and how these labeled arrows work under the hood and how it's implemented in Excalidraw, which is a Canvas-based editor for sketching hand-drawn diagrams. Any Excalidraw users here? Awesome. So before I dive into the talk, let me quickly introduce myself. So I'm Aakansha. I'm an open source maintainer. I'm one of the core maintainers of Excalidraw, React Tags, Mermaid to Excalidraw, and a couple of more libraries. These are my socials. I would love to connect with all of you. If you want to talk about front-end, JavaScript, open source, Canvas, I'm all in for that. So yeah, with this, let's get started with the talk. Let's understand what exactly are labeled arrows with the help of an interesting example. So here are two friends having some conversation. They are just greeting each other. And then one of them suggests that they want to do a conference. And then they want to decide the topic of the conference. So say they come up with web developer tooling because that looks like an exclusive topic to be focused on. And then they want to decide the name of the conference, and they come up with this unique name, SquirrelConf. And then they just get on working, and they start working on the website and preparing the announcement and rest of the work. So can you make a quick guess who these two friends are? Yeah, so can we just have a quick round of applause? Because I think to all the volunteers and Dimitri and Josh, because of them, we are here today. So basically, this is a usage of labeled arrows where you can represent the communication, the direction, the flow in any diagram, any mockup, any architectural flow. So now that we are going to deep dive into this feature, let's understand what exactly the elements are involved when a labeled arrow is rendered in Canvas. So let's consider this labeled arrow, which has some text, hello, how are you? It has a line, it has arrowhead, and it has the text. So at least there are three separate elements involved when you want to render a labeled arrow in the canvas. So let's keep a note of it because we are going to deep dive into this. Now, as we are developers, whenever we want to build a feature or prototype, we have to come up with some minimal set of requirements. So let's discuss the minimal set of requirements to build a prototype of labeled arrow. So the first requirement is rendering the arrows in Canvas. We need to first understand how we can render the arrows in Canvas. Rendering the label on top of the arrow. Linking the label and the arrow so that in the code base, we know that, hey, this particular label is attached to this particular arrow, and this arrow has this particular label. So some relationship between these two. And we also want to support export to SVG so that users can actually download it. So we just have these four minimal requirements, and we'll be diving into each of it and fulfilling it one by one. So before we actually start with these requirements, let's first decide the data structure of the element, how you want to represent the element in the canvas. So for that, let's consider this bare minimal JSON, which we will be using to represent the element. It has a type, which is basically the type of the element, whether it's an arrow or a text. It has an ID, which is used to represent the element uniquely on the canvas. Each element will have a unique ID. It has the XY coordinates, which are used to position them on the canvas. The width and height are the dimensions. The points is important when it comes to arrow because an arrow will minimum have 2 points. When you have like just an arrow, it has the 2 extreme points, but it can, for a complex arrow, you can have 100 points or 1,000 points. So this basically is the collection of those points. And the arrowheads, what is the shape of your arrowhead? Whether it's a hollow triangle, a filled triangle, a bar, a circle, depending on how you want to construct it. So this is the bare minimal JSON. Now let's get into the first requirement is rendering the arrows in the canvas. So Canvas drawing API is broadly constructed into two categories. One is rectangles, where you can draw the rectangles with stroke rect or fill rect. Some of you might have used these APIs. And the other one is the paths. Paths is nothing but collection of points with the help of which you can draw any complex shape. And in this talk, we will be mainly focusing on the paths API because that's needed when you want to draw an arrow. So this is how you basically render a canvas in the DOM, give it some ID so that it's uniquely identified in the DOM. And canvas, whatever you draw in the canvas will stay inside the canvas. You cannot inspect anything from outside. So to interact with the canvas, you will need the context. And you basically get the context. And before starting any path, we need to call the begin path API. So once we call this begin path API, we can now start drawing a path. So let's consider this example where I want to draw an arrow starting from the XY coordinates and I have this pen. So what we can do is move the pen to XY, which is 10, 20, then draw a line to, let's say, 210, 20. The line is still not visible, so call the stroke API so that it's visible. And then again draw a line to some coordinate 190, 0, which basically draws one half of the arrowhead. Then come back to the initial point with the move to API, and then draw another line, which basically draws the rest of the arrowhead. So as you can see, this we just rendered the arrow in the canvas, but it's nothing but the combination of move to, line to, and the stroke APIs, that's all. So if you know the coordinates, you can just play around with this APIs and you can actually render any kind of arrow. So this was a simple 2-pointer arrow. Now let's look at what happens when you have, let's say, multi-point arrow. For example, this has 4 points. So let's consider like a comma b, a plus width comma b, a comma b plus height, and a plus width comma b plus height. These are the 4 points, and I want to render this arrow in the canvas. So following the similar logic, we'll just use the combination of line to, move to, and the stroke APIs, that's all. So we just draw the first line with line to and the stroke API. Then you draw the second line with the line to and stroke API, then the third line, then the arrowheads. Now here, if you notice, we are calling the stroke API 4 times, which means whatever number of points you have, that is that many times you will be calling the stroke API. Now imagine if you have 100 points or 1000 points, then you will be calling the stroke API that many times, which can turn out to be expensive. So instead of that, we can actually batch all these calls and call the stroke API just at the last, and that can actually help us optimize the performance a lot. So I have a quick demo to show that. Let's go to that demo. So in the left side, I'm actually rendering an arrow which basically calls the stroke multiple times. For every point, I'm calling the stroke, as you can see here in the loop. And on the right side, I want to render it by calling the stroke API only at the last. So basically, that's what I am referring as single polyline. So let me just copy the same code here in the single polyline. And what I'm going to do is I'm just moving the stroke API outside because I just want to batch all of them together. And let me uncomment this so the performance can be tracked. Now, if I try to call it for 100 points, you will notice there is not much of a difference. It's like 0.1 millisecond versus 0.4 millisecond. So 4x faster. For 1000 points, you can see there is some difference. The single polyline is taking 0.3 millisecond versus when you are drawing for each, you are calling stroke multiple times, it's 6.4 millisecond. Now, I can't go beyond this, but I would like to show you what happens when you have immensely high number of points. So I have a quick demo, a recorded demo, which I want to show you for this. So in this one, if you notice, for 10,000 points, it's actually taking 0.7 millisecond for single polyline, but 159 milliseconds for multiple lines, basically multiple stroke calls. And beyond this, it will just crash my browser. Like this happens in my laptop. So it's something which you should be cautious when using the stroke API. So yeah, so batch the stroke calls when you have rendering the multi-point lines. So in Excalidraw, we don't have to deal with the low-level APIs because we have rough.js. We use rough.js, which is a fantastic library. It is basically it provides you sugar-coated APIs to render the shapes. And if you have used Excalidraw, you will notice those hand-drawn feelings, the curviness, the slopiness, the roughness, that actually comes from this library, and it's by Preet. So yeah, you should definitely check out this library. It's a really good library. So now the first task is complete. We are able to render the arrows in Canvas. Now let's move on to the next one, which is rendering the label on top of the arrow. So first, let's understand how do you render the text. So for rendering the text, you basically take a text and get the context of the canvas and assign it with some font. Excali font is what I'm using, which is basically an improved version of Virgil font. And give it some fill style, the color, and call the draw text API, and it will render the text. So this is what the text is getting rendered, hello squillconf with a smiley. Now let's say if I have a multi-line text. Let's say I have, hello everyone, I just love everything about squillconf. Josh and Dimitri are the best organizers. So this is a multi-line, and if I want to render it, this is how it gets rendered. If you see, it's just getting rendered in a single line. This is because Canvas doesn't support multi-line. So in that case, what we have to do is, if you want to render multiple lines, we have to take care of ourselves. We have to render them individually. So what we need to do is, first you split it by /n, and we come up with our own line height, basically the vertical distance between each line, so that you can position the line in the canvas correctly. Line height is basically the concept of the browser. If you don't assign line height, you would have seen that each browser calculates its own line height. So it's recommended when you want to have a hard-coded line height, you should use 1.2 and 1.25. And to render it on the canvas, you just multiply it with the font size. So that gives you basically the vertical distance between two individual lines. And that's how you render it on the canvas. So with this, we can actually render the multiple lines. Now, it comes to rendering the label on top of the arrow. This is how it will get rendered. But this is not what we want. We want to actually clear that overlapping area in the arrow where the text is overlapping it. So for that, we have two approaches. We have a clearRect API, which the Canvas provides you, and we have clipping. We will be trying these two approaches, and we will see how both of them, what are the pros and cons of both the approaches. So for that, first we need to understand how we compute the dimensions of the text. So for height, since we ourselves are computing the vertical distance between the two lines, we can use the concept of font size into line height, and we can get the height of the text, height of this particular line. And for width, Canvas gives you a measure text API, which basically helps you to compute the width of a given line. So there is a limitation again. Since Canvas doesn't support multi-line, so measure text also doesn't work with multi-line. So if you give it a multi-line text, it will not work. So what we need to do is, you again split the multiple lines individually and compute the width of each line, and then take the maximum width, because that is the safest width to take. So for example, in this case, there are like 6 lines, and the largest width will be for this particular line, page when looking at it, because this has the largest width, and this is the safest width to take for the entire content. So that's how we actually compute the width using the measure text API. And for height, it's pretty straightforward. You know the line height, you multiply it with the font size, and you just multiply it with the number of lines, and you can compute the height of the entire text. So you have the width and height in place. Now we can use the clearRect API. So basically, clearRect API, what it does is, you basically give it the coordinates and the text width and height, the area which you want to clear. So this API will basically remove the pixels from this particular area. And this is only happening on the arrow. So basically, we are removing this part of the arrow. And when you do that and you render the text, it basically, this is what we want. The area is removed. And now if you see, the label feels like it's part of the arrow. So this is what the expected behavior is. So clearRect is very simple to use, very straightforward to use. Now what happens when we want to try out clipping? That is the next approach. So in clipping, let's consider this particular rectangle, which is basically, I'm just creating a rectangle with some coordinates and some style. And now you actually again need to call the begin path API, as I mentioned, and you call the rect API for clipping. So this is the area which I want to clip. The black rectangle is what I want to clip. So if I call the clip API, this is what happens. Basically, the entire shape just gets converted to this particular clipped area, and that is what you are left with. So that is the concept of clipping. So whatever path you give, that entire shape gets clipped to that particular region. So this was just a small rectangle. Let's consider if you have like 2 rectangles. Now if I call the clip path, again, I'll be left with this because that's what I'm trying to clip. But there is an interesting parameter which it takes, a second parameter, the clip API. In that, what happens is when you have multiple paths in the clip, in the intersection region, wherever the intersection happens, for example, in this case, this is the intersection region, a hole will be created if you pass a parameter which is even odd. This is one of the parameters which is optional, but if you pass it, a hole will be created in the intersection region of the clipping. And this is an important information for us because this can help us in the labeled arrows. So what we can do is, with the help of this, we want to basically have this entire region to be viewable, or the rectangle which you can see, because this entire arrow should be visible. But at the same time, the text region or the text dimensions, that is where I want to remove the part of the arrow. So basically, I want to create a hole here in the arrow. So where the intersection region, I want to create a hole. So that's how we can utilize the clipping to create a hole. So now let's actually try this out. And after this, you will achieve the same result which you had in clearRect. So I just have a quick demo to show you the performance difference between clearRect and clipping. So let's go to that. And yeah. So this on the left side, I'm basically rendering it with clearRect. On the right side, I'm trying to render it with clipping. So right now, the clipping I have not added the approach for clipping, so you can see that it's getting overlapped. So let me just add some fill style, maybe some red color, just to show you which area I'm trying to clip. And maybe I'll just add the arrow width plus 20, just to give you an idea what is the part which is going to get clipped. So if I refresh this, this is basically the outer region which I was denoting earlier, where the entire arrow should be visible. And now I want to add a rectangle for the text dimensions. So let me maybe add a fill style with maybe white color so it's visible. And fill rect with text dimensions and line height. So now if I refresh, so this is basically where I want to create the hole, the white region. So this is just to show you that this is basically what I'm trying to clip. So let me now uncomment this and now just let me comment this as well. And now if I refresh it, it will not work. The hole is not being created because, as I mentioned, unless you pass the even odd parameter, it will not work. So now if I pass the even odd parameter, you can see the gap is created. And let me uncomment this one. And now you can see that I'm able to achieve the same with like the gap is created, and now I'm able to render the text. So now if I just compare the performance here for, let's say, 1,000 iterations, you can see the difference. Again, 302 milliseconds with clipping, and without clipping, it's 16 milliseconds with clearRect. So clearRect is a lot faster than clipping. And I cannot go beyond this in my laptop again for the same reasons which I showed earlier. So, but I can show you a quick demo which I have a recorded version. So let's just go through this demo once. Clipping is a very expensive API again. So if I go beyond 1,000, let's see what it looks like. So if you notice here, if it's like 10,000 times iterations, basically I'm rendering 10,000 times, then the clipping is taking something like 12,551 milliseconds, whereas clearRect is just taking 120 milliseconds. And after this, the browser will just crash. So again, be cautious with the clipping API. Unless and until you have the need, we should not use the clipping, because this is not, in here is just clearing a rectangle, which is a very simple region. So for this, clipping is not recommended. And after this, you can just render the text area on top of the canvas so that user can actually start typing into it. And if you notice, all the stylings are removed, margin 0, padding 0, border 0, because we want to make the users feel that they are actually typing into the canvas and not really some DOM element. So this is just to make the user experience better. So with this, the second requirement is fulfilled. Now, the third requirement is linking the label and the arrow. So in here, basically, let's have some assumptions. A single arrow can have a single label, and a label can be attached to only one arrow. So it's basically one-on-one relationship. And with this in mind, if you want to create a relationship between a label and its arrow, let's go back to the JSON, which I showed you a couple of minutes back, where you have these attributes. Since every element has a unique ID, so what we can do is we can add a label ID to the arrow, which will basically denote the ID of the label which is attached to this arrow. So if an arrow has a label ID attached to it, it means that it is a labeled arrow. Otherwise, it's a regular arrow. Similarly, in the text, you can actually add an attribute, let's say container ID. And if a text has a container ID, it means that it is attached to some container, which is an arrow. And if it doesn't have a container ID, it's just a regular text. So with this in mind, we have built a relationship between the arrow and its label, label and its arrow. And now, if you notice, if I try to move the labeled arrow, I can just check that, hey, this arrow has a label ID, then let me move the text as well. If I try to copy the arrow, I can check whether it has a label ID, then let me copy the text as well. If I try to resize it, I can just check if it has a label ID, let me resize the text as well. So whatever actions you are applying on the arrow will be replicated to the label. And because under the hood that these two are separate elements, that is something which we are aware of, but for the users, it should seem like that it's a single element. So with the help of this relationship, we can achieve this. So with this, the third requirement is fulfilled. And now we have the fourth and the last requirement, which is supporting exporting to SVG. So let's just understand quickly how you can render an arrow in SVG. So this is the same arrow which I rendered in Canvas. And here, if you notice, SVG is basically in DOM, you can inspect it. It's vector based, unlike Canvas. And you have these path elements which you use to create the path. So here, M basically stands for move the pen to 20,20, and L stands for draw a line to 200,10. Now let's think about the canvas, and you can visualize it that it's nothing but it's the same APIs written in a different way. So can move to line to stroke is represented in a different way when you are using it in SVG, but it's actually the same thing. That's how I understand it. So this way you can actually render the arrows in SVG. And we want to actually render the label on top of the arrow again. So we did this with clearRect and clipping in Canvas. Now let's see how we can do the same with SVG. So again, width and height is something we already know. We have already computed the width and height. So we will be using the same dimensions. In SVG, there is a concept of masking. So what masking means is there are two rules in masking. We have to remember white means revealing the area. So if you have a shape where you are applying some mask, the region which is filled with white will be transparent. The region which is filled with black will be hidden or opaque. So these are the two rules we need to remember. White means transparent, black means opaque. So let's consider the same red rectangle, which we saw a couple of minutes back. And now I want to add some masking to this. So this is how you can add the masking. You add it in the definition attributes and create a mask element and add some ID to it. And this is the same ID which you will be using in the element where you want to add the mask. And now I want to add the masking regions. So let's say we have 4 masking regions. And you can see all the 4 regions have different level of transparency. But if you notice, the second one is fully invisible because it is filled with black. That's why it's opaque. But the fourth one is fully visible. It was originally the red color and it is fully visible because it is filled with white. So that is what I just mentioned, that white means transparent, black means opaque. So this was the original shape, and this is after the applying the mask, and the rest of the two regions have different levels of transparency depending on the color you are applying. So this concept we can actually apply to labeled arrows. The entire arrow, I can fill it with white because I want it to be visible, but the text area, the dimensions of the text, that area I can fill it with black because I want to hide the pixels or hide the part of the SVG in that. So that this entire part of the arrow basically will be opaque. And then I can render the text on top of it. So this is the same masking concept. So let's see how it looks. You can see I have two rectangles. One is filled with black and one is filled with white. And I have the arrow, the path of the arrow elements. And the text is outside the arrow. The text is outside the grouping. G is basically used to group multiple elements. And I am basically enclosing it, the arrow paths into the grouping element, and text is outside it. So now if I want to create a mask, I'm assigning it an ID and applying the same to the grouping element where I want to apply the mask. And then if I try to move the white rectangle inside the mask, the arrow should be visible. So let's see. And yes, the arrow is visible now because it was filled with white. Now, if I move the black area, then that part of the arrow should be hidden and the text should be visible now. So that's what happens. So this is how the masking works. So with this, we can achieve the rendering the label on top of the arrow, similar to how it is in Canvas. And with this, SVG is done as well. So now I just want to talk a little bit about the performance improvements which we can actually push to make this feature and enhance it a lot better. So this I already mentioned that drawing a single polyline instead of multiple lines is a lot better and a lot more performant. Using off-screen canvas can be very helpful. So by off-screen canvas, I mean the canvas is not rendered on the DOM. It's basically used to cache the elements, and instead of painting the canvas every time, you can just copy that cached canvas onto the main canvas with the help of Draw Image API. So it's like taking a snapshot and copying it to the main canvas. And this actually helps to improve the performance a lot. Let me just show you a quick demo for this. So in the left side, I'm basically not doing any caching. I'm just rendering the text multiple times as you normally will do. And as you can see, I'm calling the draw text multiple times. But on the right side, I want to actually cache it. So let me just render it here. Calling the draw image API. So I have already created a temp canvas and I'm drawing the text onto it. So I just call the draw image API here. And I need to pass the canvas and the coordinates. And now let me just refresh it. So now let me see, for 100 elements, the time taken is 0.4 millisecond versus 2.2 milliseconds. So with draw image, it's faster. Let's see, for 1,000 elements, it's 50x faster, 2.4 versus 36.4. And for 10,000, it's a lot more faster. So as you can see, the performance actually varies a lot. And that's why you should always cache the elements or cache the repeated elements. It's not just limited to labeled arrow, but any particular feature where you feel that you are repeating these steps, just move it to the off-screen canvas. Avoid floating point values since it leads to expensive calculations. This is something which is mentioned in the docs. So you always should round off the integers. Rendering arrow in paths can actually improve the performance to a great extent. This is something interesting which I recently came across. So by rendering it in paths, I mean draw the first half of the arrow before the text, then render the text, and then render the rest of the arrow. So instead of using the techniques like clearRect and clipping, I'm basically breaking it into 3 steps. And this actually turns out to be faster. Let me just show you a quick demo for this. This is the last demo. So left side, I'm doing clearRect, and the right side, it's using the, it's basically rendering it in parts. So let me just try it with maybe 10, I think 4 second, it's taking 0.4 versus 1.5. Let me try it with 1,000. You can see that it's 4.2 millisecond versus clearRect takes 120 milliseconds. And if I go a little beyond 10,000, it's 41 milliseconds versus 1,000 or 1350 milliseconds. So this is faster, but this is complicated to implement as well, depending on the shape of the arrow, because you have to compute these 3 parts separately. So with this, I would like to wrap up with the takeaways. What we have learned so far, we learned about the labeled arrows, how to render them in Canvas. Canvas doesn't support multi-line, so that needs to be handled. clearRect versus clipping, clearRect is a lot faster. And always try to use off-screen canvas when you have the repetition. If you are repeating some steps, just move it to the off-screen canvas. Single polyline is more efficient than multiple polylines. Floating point values we should definitely avoid and always round off to integers. Rendering labeled arrows in SVG and masking to remove the overlapping area. And drawing arrow in paths seems to be faster, but it can turn out to be complex depending on how complex your shape is. This is the repo with all the demos. It would be great if you can try it out in your device, because the result might differ depending on the device and the browser. And yeah, these are my socials. If you would like to connect with me, I would love to connect. And as an independent maintainer, I rely on sponsorships. So yeah, if you want to back my open source efforts, you can check out my sponsorship profile. And yeah, that's it from my side. Thank you so much. Thank you for having me.
Okay, first off, if you have to support exporting to SVG anyway, why render to Canvas and not just to SVG directly?
Okay, this is an interesting question. So when Excalidraw started, it was started by Viju from Meta, and it started with Canvas, because when you want to build something with drawing, I think Canvas is the first thing which comes to your mind, and you get a lot of performance benefits. So that is the reason we went ahead with Canvas. It was just an instinct decision. And then down the line, we want to support a lot of features, and that's how SVG came in. So yeah. But yeah, it depends. Both approaches are fine. You can also move ahead with SVG, but there are pros and cons, I would say, in both the approaches.